Welcome back to math class today. We have ratios lesson number 10. We're going to be working with unit rates again today, but today we're going to be working with speed and time. So let's do a quick warm up. It asks us to find the value ratio. The value ratio means it's the ratio scaled all the way down as far as it can go. So as I'm looking at these ratios here, A is 40 to 8. I could scale that one down by dividing them both by 8. So that would be a ratio of 5 to 1. So the value ratio for A is 5 to 1. So that one is not currently a value ratio. 10 to 60, I could divide both of those by 10 and scale it down by 10. So that would be a value ratio of 1 to 6. That one is not currently a value ratio. 8 to 10, I could scale down by 10 and get 8 to 1. That's the value ratio, so 80 to 10 is not. 4 to 5, I cannot scale down. 4 to 5 then would be the value ratio because I cannot scale it down any further. 3 to 18, I could scale down by 3 and get 1 to 6. So the value ratio would actually be 1 to 6. All right, so today's objectives are to be able to find the unit rate when dealing with time and to find the unit rate in dealing with speed. So again, it's just the learning target of being able to find unit rates in real world situations. So let's get started. Jordan ran 4 laps in 5.8 minutes. What would be the rate if he ran at a constant speed for all 4 laps? So we have a current rate of 5.8 minutes for 4 laps. That's not a unit rate, that's just his rate. We want to find the unit rate, which means we are going to scale it down to 1 to find for 1 lap. If he ran at a constant speed, how fast is he running per lap? So we're just going to do our division. We're going to divide to get to 1, if you remember our song from last time. So 5 8/10 divided by 4 is 1 45/100 minutes per lap. So his rate is 1.45 minutes per lap. So that's all we're doing today. The exact same thing, we're dividing to get to 1. It's just that instead of doing money, like we've been doing in the last couple lessons, we are doing time and distance. So let's try another one. An industrial machine is able to make 9 pens in 3 seconds. What is the rate made per second? So our rate is 9 pens in 3 seconds. We want to know the rate per 1 second. So we want the unit rate. So we divide to get to 1. So we need to divide by 3 in order to get to 1, which this rate tells us anyway. That's just 9 divided by 3. So 9 divided by 3 is 3. So they are making pens at a rate of 3 pens per second. So that is our rate per second. Sally is traveling to Florida for vacation. Her flight takes off and the plane travels at a constant speed of 337 miles per hour. It takes 5 hours to get to her destination. How many miles did she travel? This problem is slightly different. We are given this right here, 337 miles per hour. We already have the unit rate. We know how far she's traveling per 1 hour. So we're not trying to find the unit rate. We're trying to use the unit rate in order to find her distance if she traveled for 5 hours. So we've got to be careful when you read these problems to know if you're given the unit rate, if you're being asked to find the unit rate, because it makes a difference. So we want to know how far she goes in 5 hours. So to get from 1 hour to 5 hours, I would multiply by 5. So I'm going to do 337 times 5 in order to get my equivalent ratio, and it's 1,685 miles. So how many miles did she travel in 5 hours? She traveled 1,685 miles. All right, Ken can walk 40 dogs in 8 hours. How many dogs can Ken walk in 12 hours? So in this one, we're neither given the unit rate nor asked for the unit rate. We have 40 dogs in 8 hours, and we want to know how many dogs he can walk in 12 hours. So we can't get directly from 8 to 12 by scaling up, at least not with a whole number. And so it might be helpful for us to find the unit rate, like we practiced doing when we first did Better Buys and unit rate with price. Find the unit rate and then scale back up. So if I have 40 dogs in 8 hours, if I divide to get to 1, that means I have 5 dogs per hour. That's my unit rate, but I want to know in 12 hours. So to get to 12 hours, I times by 12. So I'm going to do that up here as well. And 12 times 5 is 60. So Ken could walk 60 dogs in 12 hours. So again, we needed to scale down to find the unit rate, and then we needed to scale up. You could have also scaled down by 2 and gotten 20 dogs in 4 hours, and then times that by 3 to get to 12 hours as well. So you could have done it without the unit rate if you wanted to. All right, Shanna rides her horse for 9 hours a week and travels a total of 36 miles. How many miles per hour does Shanna ride her horse? So you can see here what we're looking for is miles per hour. That is a unit rate. That word per right there helps us know that. So we're given a rate. We need to find the unit rate. So we want to divide to get to 1. So we have 36 miles in 9 hours. So let's scale that down by 9. Let's do 36 divided by 9. And that means she is going 4 miles per hour. So how many miles per hour does Shanna ride her horse? 4 miles per hour. All right, let's do a fill in the table problem here. Bonnie loves to jog in the mornings. If she jogs 1 mile every 9 minutes, how far would she jog in 72 minutes? Complete the table. So we know 1 mile every 9 minutes, that's her unit rate. She's doing 9 minutes per mile. So we're not trying to find the unit rate. We already have that. We're going to use the unit rate to then fill in and find some equivalent rates. So 1 to 9. So to get from 1 mile to 3 miles, I times by 3. So I'm going to do that same thing here. 9 times 3 is 27. To get from 9 minutes to 45 minutes, I times by 5. So I'm going to do that same thing here. I'm going to times by 5. So 1 times 5 is 5. So 5 miles to 45 minutes. To get from 9 minutes to 72 minutes, I times by 8. So I'm going to do that same thing over here. I'm going to times by 8, and 1 times 8 is 8. So all of those ratios, 1 to 9, 3 to 27, 5 to 45, and 8 to 72, are equivalent ratios. So it asked us how far would she jog in 72 minutes. So if I were looking for the answer to that question, it looks like she would jog 8 miles in 72 minutes. Johnny drives a long way to go buy donuts. He drives a total of 7 hours each week. That must be some good donuts he's getting. If he drives exactly 343 miles each week, what is his rate of speed? All right, put the video on pause and see what you can do to solve this problem on your own. Okay, if Johnny is driving 343 miles in 7 hours, I am looking for his rate of speed, which means I'm looking for the unit rate. I've been given a rate of how fast he's traveling, but not the unit rate. So I need to scale it down to 1. So I have 343 divided by 7. And if you do that correctly, you will get 49 miles in 1 hour. So that right there is his rate of speed. He is traveling 49 miles per hour. All right, this one's a little bit trickier. Carol runs on a treadmill for 25 minutes. She runs a total of 3,200 meters during her workout. Which of the following statements is true? All right, so we look at these. Carol traveled 128 meters per minute. Well, that's a unit rate, so it looks like I would need to find out what that is to know if that statement is true. So 3,200 meters in 25 minutes is 3,200 divided by 25, which is 128. So 128 meters in 1 minute. So that statement is true. She traveled 128 meters per minute. Is it also true then that she traveled 640 meters in 4 minutes? So to find that, I would then need to scale this up by 4. So I would need to do 128 times 4, and that gives me 512 meters in 4 minutes. So that statement is not true. Carol traveled 1,000 meters in less than 7 minutes. Well, let's see what she traveled in 7 minutes. So I'm going to have to do 128 times 7 to figure out how far she went in 7 minutes. So in 7 minutes, she traveled 896 meters. So it doesn't look like that she traveled 1,000 meters in less than 7 minutes, because in 7 minutes, she hasn't even gone 1,000 meters yet. It would take Carol 50 minutes to travel 7,000 meters. 50 minutes to go 7,000 meters. And delete these so that I can have a little bit more space to write here. Okay, so let's see. 128 meters per minute. So let's see in 50 minutes how far she went. So I'm going to times that by 50. And that is 6,400 meters in 50 minutes. So it would take Carol 50 minutes to travel 7,000 meters. Nope, it's going to take Carol longer than 50 minutes. So the only statement there that's true would be A. All right, turn the video on pause and try this one on your own. So Conrad rides his bicycle 85 miles in 5 hours. Determine if the following statements are true or false. So Conrad travels 51 miles in 3 hours. Well, to go from 5 hours to 3 hours, I think my easiest bet is going to be to find the unit rate all the way down to 1 and then scale up. And it looks like I'm also finding 6 hours and 30 minutes. And so it looks like a unit rate is going to be the most helpful thing for me here. So if he traveled 85 miles in 5 hours, I'm going to write it up here. 85 miles in 5 hours. I'm going to do 85 divided by 5. And that is 17. So he's traveling 17 miles per hour. So does he travel 51 miles in 3 hours? So I'm going to have to do this, and I'm going to need to times it by 3. And 17 times 3 is 51. So he does travel 51 miles in 3 hours. So that statement would be true. Does he travel 119 miles in 6 hours? Well, I'm going to need to multiply this one then by 6 in order to figure that out. So 17 times 6 is 102. So 102 miles in 6 hours. So that statement would be false. He travels more than 119 miles. Or no, he doesn't travel 119 miles in 6 hours. He only travels 102. Conrad travels 8.5 miles in 30 minutes. So in order to find 30 minutes, I need to actually divide this. 30 minutes is half of an hour. So I'm actually going to scale this down by dividing by 2. So I get 30 minutes, and 17 divided by 2 is 8.5. So he gets 8.5 miles in 30 minutes. So it looks like that statement is true. Conrad travels at a rate of 18 miles per hour. We already found that. He travels at a rate of 17 miles per hour. So that one is not true. It would take Conrad more than one day to travel 500 miles. Well, one day is 24 hours. So let's see how far he travels in 24 hours. So I would need to times this, scale it up by 24. So 17 times 24 is 408. So he would travel 408 miles in 24 hours. And so it would take Conrad more than one day to travel 500 miles, because in one day he traveled only 408. So that would be a true statement. That one was false. That one was true. I'm going to erase those. So that's what our table should look like. Okay, Dexter ran 162 laps around the school gym in 54 minutes. Complete the table that shows Dexter's progress throughout his week. Try this one on your own. Pause it, fill out that table, and then turn it on and check and see how you did. All right, so 162 laps in 54 minutes would be 162 divided by 54 to find the unit rate. That is 3 laps per minute. So in 1 minute, he went 3 laps. So then to go 7 minutes, I would times it by 7. So that would be 21 laps. To get to 57, I would need to times by 19. So in 19 minutes, he went 57 laps. And to get from 1 minute to 23 minutes, I would need to times by 23. So 3 times 23 is 69. In 23 minutes, he would have gone 69 laps. That's what your table should look like. A bus gets bad gas mileage. It can only travel a total of 6 miles per gallon of gas. The cost of gas is high. It costs $4 per gallon. What is the cost of the gas that will be used if the bus covers a distance of 96 miles? So ultimately, we're looking for the cost of the gas. But before we can find the cost, since it's in cost per gallon, we need to figure out how many gallons the bus used. So if the bus goes 6 miles per gallon and it went 96 miles, we would need to divide 96 by 6 to figure out how many gallons of gas it used. So the bus used 16 gallons of gas, because for every 6 miles, it used 1 gallon of gas. And then it's $4 per gallon. So I would need to then times my 16 by 4 to figure out how much money I would pay. And 16 times 4 is $64. So it would cost me $64 to go 96 miles. That is a lot. A motorcycle wheel rotates 480 times in 4 minutes. Cooper says that the unit rate is 120 rotations per second. Milan says the unit rate is 2 rotations per second. Which of the following explains who is correct? All right, so if I were finding the rotations per second, I would do 480 rotations in 4 minutes. And that is minutes, not seconds. So that is where it gets a little bit tricky, because these guys are both giving it in per second. Okay, so this would be, I would divide by 4 and I would get 120 rotations per minute, but there are 60 seconds in a minute. So that would be 120 in 60 seconds, which is actually 2 rotations per second. So it looks like Milan is the correct one that says 2 rotations per second. So you have to be careful looking at the rate or the measure there. This one is minutes and this one is seconds. Cooper is correct because 480 minus 240 is 240. Nope. And we know Cooper's not correct. So I know it's not A and I know it's not B. Milan is correct because 480 divided by 240 is 2. So 240 would be how many seconds 4 minutes is. So if we had converted the 4 minutes to seconds, that would be correct. Looking at the last one, Milan is correct because there are 4 minutes in 480 seconds. Nope. So the reason why Milan is correct is C. Right there. Because 480 rotations in 4 minutes. If I convert minutes to seconds by multiplying by 60, that's 240 seconds. So then I would divide to get to 1. So 480 divided by 240 is 2. So that gives you 2 rotations per second. All right, that's it for today. So you are on your own now on your assignment. Good luck with that. Remember to pay close attention to whether you're given the unit rate or whether you're finding the unit rate. That will help you in knowing what you need to do.